In this video, I'm going to provide a bit of a background on a research project that I'm calling the Newsomatic. The Newsomatic is a prototype that is designed to explore the changing physicality of news consumption and the lack of user agency in algorithmic digital journalism distribution through the development of an audio-based digital news device. Created using a single-board computer, a custom laser-cut enclosure, and by embracing physical computing approaches, a prototype of a digital audio device was created that allows for users to control the content of an audio-based news bulletin using tactile knobs and buttons. This project was built using a Raspberry Pi 4B with 4 gigabytes of memory. Connected to the Pi via its GPIO pins are 5 knobs and a button. These connections between the GPIO pins on the Pi and the button and knobs are made via a mini solderless breadboard and a combination of DuPont style and soldered connections. As the Pi doesn't have the capability to process analog inputs, an MCP8000 analog to digital converter chip was used to read the analog values from the knobs. A custom laser cut case was also created for this project, which was used to house the Pi and the mini breadboard and also serve as a mount for the knobs and buttons. The programming for this project was done using the Python programming language. 3 Python scripts were created for this project, which I will go through in a little bit more detail later on in this video. And those 3 scripts serve as the functional brain of the Newsomatic. The first one is a article grabber, grabbing articles from RSS feeds, publicly available RSS feeds. The second file is an article summarizer. And the third and final main file is the news creator itself, which essentially creates a MP3 of a news bulletin using text-to-speech. The article grabber script reads news article website addresses from user-defined RSS feeds, scrapes that article information, and then stores that information in a MySQL database. The article summarizer script uses the Transformers Python library to automatically create a summary of those articles, and again stores that summary in a database on the Pi. Finally, the newscast creator script senses when a button is pressed on the Newsomatic, reads the values of the knobs, and then creates a text radio script based on those values, which it eventually converts into an MP3 using, again, text-to-speech. Each knob is dedicated to one subject matter. In the case of my example, the subjects are Canada, world, business, sports, and politics. If you turn a knob clockwise, you will get more of that subject in your news bulletin. As I said, the text script is converted into an audio newscast using either Google Cloud text-to-speech functionality or the more free PY or Pi TTSX3 Python library, and it is then played over a speaker connected to the Pi when it's converted into an MP3. All of the Python files for this project are available on my GitHub, and the repository is linked in the description of this video. So you're going to need a few things if you would like to kind of recreate the Newsomatic on your own. The first one, of course, is a Raspberry Pi 4B. I have the version with the 4 gigabyte version. You will also obviously need a micro SD card to have your OS for the Raspberry Pi, and you will need some form of USB power supply. You will also, in the case of how I have set it up, need some form of breadboard. You will also need the MCP3008 analog to digital converter, because as I mentioned, the Raspberry Pi can't read analog inputs as it's set up by default. You will also need DuPont style connectors. I use both female to male and male to male types of connectors. You will need some knobs, or potentiometers as they are called, and you will need a button. I will put links in the description of this video for where I got some of my versions of these things, but you may have some of them yourself already. Before we look a little bit more closely at the code for this project and see the Newsomatic in action, I wanted to talk a little bit more about some of the choices that I made for this project. Please keep in mind that this project is still a bit of a work in progress, and there's some definite improvements I'd like to make in the future related to this project. As I mentioned, for this project I used the Raspberry Pi 4B with 4 gigabytes of memory. This was mostly because at the time of starting this project, models with the 8 gigabytes were not available. This project could potentially work with Pi models with less memory or older Pi models such as the 3, but the text summarizations done with the transformer libraries are a little bit processor intensive and would probably run much slower on older models. I installed the 64-bit of the version of the Raspberry Pi OS, Bullseye on the Pi, but this project could probably also work on 32-bit versions as well. The Pi used in this project uses a 32 gigabyte SD card for storage, but I think smaller cards such as a 8 gigabyte one or a 16 gigabyte one should also be fine. Most of the file space on those cards is taken up by the operating system. The files themselves are not actually that large, the MP3s that are created as part of the Newsomatic. The Pi that I purchased only came with passive cooling, but the Pi gets pretty hot, around 80 degrees Celsius, while doing the text summarization, so I imagine an active cooling via a fan would probably be a little bit of a better approach. But I was trying to keep this relatively low cost, and I had to fit everything into the custom laser cut enclosure, so I stuck with the passive cooling, but active cooling would probably work a little bit better. As I mentioned, I use a breadboard for this project. My final version of the project, I actually used a mini breadboard so that I could fit the breadboard into my custom case, but any size breadboard would be fine. You could also use some form of prototyping board and solder most of the connections for this project. I wanted to be able to change my connections around a little bit more, and I'm still not really great at soldering, so I mostly use DuPont style connections. I soldered, when I did solder, I used 22 gauge wire to wire the leads of the knobs and the buttons. But in the end, most of the connections were used by DuPont cables. And in the case of the knobs that I purchased, you can actually, and I did this a little bit, you can actually use the DuPont style connectors with them as well. You can kind of just shove them right in, and they work relatively okay on the leads for the knobs. But for the button that I purchased, I definitely had to solder it. As I mentioned, for this project, I used 5 different 3-pin linear rotary potentiometers with varying resistor values. At least in my case, the resistor value didn't seem to matter that much. They were all in like 5, 10K, maybe even 1000K range. I purchased a kit from Amazon that included the potentiometers, plastic knobs to go on top of it, and nuts and washers. To work with my case design, specifically with these knobs, I had to file down a little metal tab that protruded from those potentiometers. And apologies if I'm pronouncing that improperly. As I mentioned, I also had this project requires a button as well. Any button that really connects and allows you to connect an input and a ground to it should be fine for this project. I first used the small button that is included in many electronic kits, but I found this style of button challenging to properly mount to my case. So I switched to more of an arcade style button, which worked far better. It was much easier to mount onto the case. This prototype is reliant on the MCP 3008 analog to digital conversion chip to convert the analog signals from the knobs to digital signals that can be read by the Pi. This really great tutorial and video from Robotica DIY outlines how to connect the knobs to the Pi. In broad strokes, in my case using DuPont female to male connectors, I connected pins 9 through 16 on the MCP 3008 chip to specific GPIO pins on the Pi. And this page does a really great job of outlining where each of those pins connects to the GPIO in the Pi. And then in the other side of the chip for pins 1 to 8, these essentially act as inputs that you can then read the analog inputs from the knobs from. And you essentially connect the middle pin in the 3-pin knobs to each one of these input channels on the MCP 3008. And then the other 2 pins on the knobs are connected to both the 3v3 power on the Pi and the ground in the Pi. But this website, as I mentioned, does a really great job of explaining how to do it. But essentially all of these pins on this side of the chip are connected to the GPIO of the Pi, and then all of the ones on the other side act as analog inputs that you can use to connect directly to your knobs. And this page goes through all of the different things that you have to kind of configure for the Pi itself, including a key one enabling the SPI on the Pi. In this case, they're trying to control the brightness of an LED, but you can get a little bit of a sense of how the connection works either way. So it gives you a little bit of a pin readout as far as how you would connect it to a breadboard. You can just kind of leave out this LED part. You can see here that the various different connections on the chip go to either the positive or ground or specific pins on the GPIO, mostly in the middle here. And then as you can see, in this case, on this kind of bottom part, depending on how you've oriented your board, you would take the middle pin of the 3-pin knob and have it go to one of the chip inputs, analog inputs, and then you would take the other one, in this case, the one on the left, connected to ground, and the one on the far right you would connect to the kind of the positive or 3.3 volt power from your Raspberry Pi. But this page goes through it in far better detail than I do. And again, I'll put the link for this page, the really great tutorial from Robotica DIY, in the description for this video. In the case of the button, I followed this really great and simple tutorial from the Raspberry Pi website. And essentially what you do for the 2 pins of the button, one side of the pins is connected to a general purpose input-output of the Pi. So in this case, they have connected it to the GP2, which is the 2nd pin on the left in this diagram. And then the other pin would be connected to a ground. In my case, I connected it like they did here in this diagram, connected it to a ground via a breadboard, and the breadboard got its ground directly from the Pi itself, and then that way I could reuse the ground for a variety of different purposes. This project also requires and uses a MySQL database, and also requires Apache and PHP, which allows for the use of PHP myadmin to administer the database. This is kind of optional, but I really like using my PHP myadmin to do the adding and tables and things like that. I followed this really great tutorial from Random Nerd Tutorials to configure MySQL, Apache, PHP, and PHP myadmin on the Pi. And I will include a link to this tutorial again in the description of this video. And in the repository for this project, I'll also include a sample database structure and a little bit of a test data as well, in case you wanted to set up the databases yourself on the Pi as well. So I wanted to go through some of the specific files that this script files and other configuration files that this project specifically uses. As I mentioned, there's 3 main files that this project uses: one to read RSS feeds, another to summarize the news articles that are gotten from those RSS feeds, and a script that essentially creates the audio news bulletins itself. Another file that's required for part of this is a configuration file called config.ini, and for the most part it allows you to make some configuration changes to the Pi for the project without actually having to change the Python programs files themselves. And so I'll go through it a little bit quickly here. I think most of the things are self-explanatory, and I go through it a little bit more detail in the GitHub page. But the first section of the ini file is this config section. So you're able to configure the amount of feeds that you will read. So in this case, I've set it to 5 because I had 5 different RSS feeds that I wanted to read from. You can also set the number of items that your newscast will have. So I, in this case, have put 10. You can also set the text-to-speech method that you would like to use within when you run the kind of create news Python file. So if you set it to Google, it will use Google Cloud text-to-speech. But if you were to change it to this, it would use the free service, free library PyTTSX3. You can also set the GPIO input that the button is connected to, and so I've set it as 4, but there's obviously several GPIOs that you could use. In the sections, the second section here, you would kind of put a few pieces of information related to the Google Cloud text-to-speech. Here you would put your full path to where you've stored your JSON credential. So this has to be the full path and not, even if this is in the same directory as your JSON credentials, it needs to be the full path to work. You can also set a couple of different settings for Google Cloud text-to-speech. So this is the language code and this is the language name. And so depending on what you set here, you can kind of change the quality and the kind of nature of the voice of the Google Cloud text-to-speech. There is also a section for your database connection. So I think by default I have it as the kind of the local host or 127.0.0.1, but you can essentially put anything in here. You would also have to put in the username that you set up for your database, the password that you connect to for your database name, and the port. And so I've named mine as Newsomatic, and the port usually is 3306, but you can change this for whatever your needs might be. And then you'll have a series of items for each one of the RSS feeds that you are going to be using to read in information from. And so as I said, in my case, I have 5 different feeds. You have an item for the URL of that RSS feed, the name of the section you want to give it, and the knob that you want to assign it to. And so these essentially correspond to the channels on the MCP 3008 chip. And so again, the first one is in channel 0, channel 1, channel 2, channel 3, channel 4. And so you can do more than 5 knobs in this case, but the naming convention of this has to kind of stay the same. So if I wanted to do another one, let's say I wanted to do 6 knobs, I can do that, but I'd have to call it feed 6. You wouldn't be able to have it be something like knob 6 or knob 6. It has to follow the format of feed and then the number. And I believe you should probably keep these sequential, so you shouldn't skip a number because it might cause some issues. So you wouldn't want to have feed 7 and skip feed 6 in this case. So if you want to add them, follows the same format, but they just have to be named as feed, the number, and then you have to follow the same process of URL, section, and knob. So the code for this project relies on a couple of different Python scripts, 3 main ones specifically, and then I also included a couple of other ones as well. This project generally requires several different Python libraries, and I won't go through all of the details on how to install these libraries, and all of these details are also listed in the repository page for this project on GitHub. But generally, it's required to have the Google Cloud libraries. You also will need the PyTTSX3 Python text-to-speech conversion library. It's a pretty good free text-to-speech conversion library. You will also need GPIO0 to read the GPIO inputs specifically for the button and for the knobs as well. I use the transformer, the Hugging Face Transformers library to do the text summarization. I also use the feed parser library to read the RSS feeds to get the article information from the RSS feeds. I use the PyTZ library to do a little bit of time zone conversion. I also use the newspaper 3K library to do some automated scraping of news articles. It is a very handy news article scraping library if you don't want to have to kind of do your own custom scraping. And you will also use the MySQL connector library as well to make your connections between Python and your MySQL databases on the Pi. So all of the details for these required libraries will be in the GitHub repository page for this project. Each one of these libraries was relatively straightforward to install, with the exception of transformers and, to a lesser degree, the Google Cloud libraries. Transformers, for the challenging part for it was that it requires PyTorch, which is a bit tricky to install on a Pi. But I followed really great instructions, which I'll include below, from a blog post on Medium, and I was able to get it to work. And so once I had gotten PyTorch successfully installed on the Pi, the rest of the kind of transformers installation was relatively easy. Google Cloud text-to-speech requires that you have a Google Cloud account, obviously, and to kind of set up that, you have to have the kind of credentials for Google Cloud set up somewhere on your computer in a JSON file on the Pi. I will include, again, a link in the description from a pretty helpful kind of tutorial from Google, which provides some instructions to do it, but it's a little bit of a convoluted process. But the big takeaway is that you have to put a JSON credentials file somewhere on your Pi, and that will kind of have to be linked to get this to work. Also note that Google Cloud text-to-speech is not a free service. You can do a lot with their free account level, but it's essentially a paid service, and so that's part of why I also included the Pi TTSX3 kind of functionality as part of this project as well. And so it doesn't create audio files that sound quite as good, but you'll be able to kind of get the sense of the general functionality of what is done with this project. So I wanted to go in a little bit more detail some of the other Python scripts that are part of this project, specifically those 3 files that kind of outline the main tasks of what the Newsomatic tries to do. The first file, read_rss.py, essentially obviously reads the information from the RSS feeds that you defined in the ini file, and then stores that information in a database. And so it takes whatever you've defined and reads the articles from those RSS feeds and then inserts them into your database. So it all kind of starts in this main function here. It reads the configuration information from the config ini file, and it sets up a database connection as well, as defined in that same configuration file. And then essentially what it does for each one of those RSS feeds, it sends kind of the information to the read feed function. So the URL of the feed, also the section name that you gave it, and the database connection as well. So then if you go up to the read feed function, it starts off with a little bit of code related to setting the time zone. So I have set mine to Canada Eastern because I'm in Toronto, but depending on where you are, you might want to set it to something different. And the one caveat with some of this is that you may have to do some tweaking of these read feed functions depending on the format of your RSS feeds. And so this works well for the feeds from the CBC, but there might be some small tweaks you might have to make depending on the format of the RSS feeds you use. But for the most part, I think it has been kept pretty generic, but just kind of keep that in mind. So one of the things it does in this first part of this function is try to determine whether the articles you're reading from the RSS feed are already within your database. And so there's a couple of pieces of code here that essentially tries to determine that. And I do it by looking for the URL. And I've done a few lines of code here that kind of clean up some of those URL things. So for example, you could have a URL with some characters at the end of it after a question mark. And so it cleans up some of that before it does some of that URL comparison. And so essentially it determines which ones are not in the database already, and it takes the ones that are not and then inserts them into the database. And it essentially uses the newspaper 3K Python library to do some of that web scraping. And so you can see here, once you've kind of gotten into the area where it's inserting to the database, it calls another function, so read body, and it essentially sends the article URL to the read body function, which is down below here. And this function uses the kind of newspaper 3K functionality to, for lack of a better word, scrape the article and get some of the information. And so it gets, in this case, mostly the body. It doesn't, in my case, I didn't need any of the title or other things that newspaper 3K can scrape, but if you did need it, you could add a little bit more information and return not just the body from this function. So essentially what it does is this line is sending the URL to the read body function, and then that function is returning the body which has been scraped by the newspaper 3K library. And so then once you have that information, it it inserts a new record in the articles table, and you can see that happening here and then the execute here. But that's essentially it. So it does that for all of the articles that aren't found in the database. And if it's already in the database, it gives a little bit of a message. And so this is a file that in my case I was running as a cron job, but you can also run it manually, just to, if you didn't want to set up cron jobs, or you're running this on your own personal computer, you could just run it manually, and essentially it'll query the database, see whether the articles that you've read from your RSS feeds are currently in that database, and if they are not, it will take that URL, will scrape the body of the article using the newspaper 3K library, and insert that information into the articles table in your database. The second file I wanted to go quickly through is the summarize.py file. The summarize.py file obviously summarizes each one of those articles using the Transformers, Hugging Face Transformers library. And it's pretty simple, similar to the previous file in that it first reads in the configuration data, reads in the database information, and then calls the summarize function with that database connection. And then you start or you create an instance of the summarization pipeline from Transformers. And then what I essentially do is I query again the articles database and look for any summaries that don't have a value set yet. And for every one of the ones that it has found that doesn't have a value, it does the summarizations for them. So one thing to keep in mind here is that there was or is a limitation on the amount of text that the Hugging Face Transformers library can summarize. So I've kind of taken the article, and it's only going to do a summarization on those first 1,000 characters, because there is a limit. And I've also set the kind of the max and min length of the summarization that will occur. So you could play with these a little bit if you find that the summarization that is coming back is too short or too long. And then once it has that summary stored in this variable, it updates each one of those table rows with the new summary. But that's essentially it. It does that for every one that it finds that doesn't have a summary set already. And again, as I mentioned earlier, this process takes quite a bit of time on the Raspberry Pi 4B. So I was finding that it would summarize an article maybe every minute or two. So if you have 100 articles to summarize, it's going to take quite some time. When I ran the same script on my desktop computer, it was far, far quicker, but the Raspberry Pi has relatively limited CPU resources, so it takes a bit of time, and this is when the script runs, the Pi also gets quite hot. So the final script that I wanted to go through was the create news.py file, and essentially what this script does is reads the values of the knobs on the Newsomatic, and based upon those values creates a text news bulletin script. And then depending on whether you've chosen Google Cloud or the more free version of text-to-speech conversion, it will create a MP3 audio file based upon that text bulletin. And so I'll go through like the other files. It kind of all starts in this main function. One of the things that I found challenging using the GPIO0 library was that when I'm kind of reading waiting for the button press, so here you have to kind of This is where you're reading in the value from the config INI file of which of the GPIO pins that you've connected your button to. So you wait for the button to be pressed. What I found with GPI 0, with some of its functionality of waiting for when a button is pressed, I couldn't send any parameters to this function, so I had to create one function, so start creation, which is here, and then in that start creation is where I pass variables to the create script function. And so unlike some of the other files in this project, I couldn't do some of those calls in the main function. I couldn't figure out an easy way to do it. So I have this function which essentially calls the function that creates the script. So hopefully that makes sense. And the meat of this whole script is done during this create script function. So essentially what is occurring here is that it's reading the values from the knobs, so the physical knobs, whether you've turned them up or down, and that's essentially how it's determining how many items from your newscast will be dedicated to a certain subject matter. And so again, depending on what you've set for your number of feeds in the INI file, it's going through each one of those feeds, getting the knob that the feed is assigned to, the topic is assigned to, and finding out what that value is. There's a little function called getKnobValue, which essentially just reads the value of the knob using the GPI 0. Again, it's using that MCP308 script, and it's getting its current value and returning it. And then essentially what it's doing is creating a little bit of a list of dictionaries that has both the section name and the knob value. And then what it does after that is kind of calculate the amount of each one of those items that will occur in the newscast itself. So you can see some of that happening right here. And what it's trying to do is, once it has those values, so again, if it's 10 and it's turned all the way up and all the other knobs are turned all the way down, you will get 10 items of that one particular topic. If you have 2 of them set to kind of halfway and all the rest of them set to 0, you'll get 5 and 5. So it's doing some of those calculations in this section here, and once it has those numbers, it's essentially querying your article database to get the summarizations from those articles, and it's slowly building up a kind of a script or a larger list of those summaries. So it's kind of putting all of those summaries together in one list, and then it essentially, depending on whether you have chosen to use PyTTSX3 or Google Cloud Text-to-Speech, it creates a MP3 from that script. And so it has 2 different functions, one for the PyTTSX3 and another for Google. And with the Google one, because it can use SSSML tags, I think that's the right acronym, I've added a few other little things to give it a little bit more of a break in between. And this is the section I might redevelop a little bit more to add a little bit more functionality as far as how that audio file actually sounds. You can do a little bit more of that with Google than you can with the free text-to-speech library. But in either one of those cases, it creates the MP3, so it calls one of these 2 functions depending on which one you've chosen. So either the make MP3 Google function or the make MP3 PyTTSX3 script creates, in both cases, it creates a file name called output.mp3. And then once that is created, it uses Pygame to essentially play the MP3. So you can see here it uses Pygame to load the MP3 as it's set at a particular volume. You can play with this if you find it's too low on your own system, and then plays it. And I think it basically waits for it to finish playing, and then if you wanted to, once it's done playing, you could then press the button again. One thing to note with this script is that if you press the button once, you have to essentially listen to the entire news bulletin, the MP3 to play before you can have the button press the button again and have it happen again. So you can't, I set it up that way so you essentially couldn't press the button a whole bunch of times and have the newscast start over and over again. So essentially if you press the button once, you'll have to wait until the audio is finished playing before you can push the button again and hear a different newscast if you want to hear something else when you've kind of changed the knobs in a certain formation. And so that's essentially how this file works. And again, I've only touched on it in brief, but there's far more details within the code itself. And again, if you have any questions related to any of these three files, please feel free to ask in the comments below. I wanted to also go through a little bit of a background on the MySQL database structure for the Newsomatic. It's relatively simple. There's essentially one database, the Newsomatic database here, and there's only really one table, the articles table. So if we look at the articles table, let's look at the structure first. There's a couple of different fields. There is an auto-incrementing ID field, and then it's mostly article information. So title, body, the publication date, which is a date, not a date time, so just the time. I don't actually have the time in here at all. And then the section. So again, this is from your config.ini file, but every one of your articles will have a topic or section, the URL of the article, and also the summary as well. So again, that is the summarization that is done by the Hugging Face Transformers library. So a relatively simple table. And again, I will include a SQL file of this structure and also a sample data file as well if you'd like to play around with it a little bit. But the data is pretty simple in my case. So, there's an ID, title, body from the text of the article. And then again, this is scraped using the newspaper 3K Python library. The publication date, again, just date, no time. The section, so in this case, all of these recent articles are the Canada section. The URL from the article, again, scraped from the RSS feed. And if a summary has been done, there will be a summary listed here as well. And so in this case, this one with ID 824 does have a summary, but a lot of the remaining ones do not have one yet at this point. And so if you were to run the summarize.py file, it would slowly run through this database and try to summarize all of these articles. So essentially, summarization takes the body and summarizes it into about a paragraph or two. So that's essentially the database structure for the project. Relatively simple, and maybe if you want to adapt this a little bit, you may want to add more fields within this table to meet your own needs. I wanted to quickly go through how you actually run these on the Pi, these three scripts that are kind of the brains of the Newsomatic. What I've essentially done is, and you don't have to do this, I've set a cron job on the Pi to run about once an hour or so to run the read RSS.py script to read the RSS feeds, and also the summarize script as well. So again, I think the way that I've set it up currently is that every hour on the half hour, it will read the RSS feeds and try to see whether there are new articles that should be added to the database. And then about 15 minutes or so later, it runs the summarize script to try and summarize those RSS feeds that have been read in, the new database entries. The read RSS script doesn't take very long, depending on how many feeds you set up within your config ini file. But as I have mentioned, the summarize.py file takes quite a bit of time. So again, depending on your model of the Pi, it may take a minute or two to summarize each one of those articles. So I've set them up as cron jobs, at least for those two scripts. If you want to edit create cron jobs on the Pi, you can use Crontab. So essentially what I've done is I've SSH'd into the Pi off of my Windows computer. And so you could also do this if you've connected a display to your Raspberry Pi. You could just use terminal on the Pi itself, but I have mine set up in a kind of headless fashion. So typically, unless I need to do something with the desktop for the Pi, I usually just SSH into it. So I have all my files within a certain directory. In my case, I've called it Newsomatic. But as I said, cron jobs, if you want to edit the cron, set up cron on your Pi, you can just go type in cron tab and then -e, and then essentially you will set up an individual line for each one of the scripts that you want to run automatically. I will put a link in the description of this video for a good, well, there's lots of them, but a good tutorial on how to set up cron jobs. But it is relatively simple. They all follow a somewhat similar format. Each one of these numbers at the beginning here represent respectively the minute, the hour, the day of the month, and the day of the week. So essentially, if you wanted to have it occur every single hour on a specific time frame, you would just put here the minutes. And so in this case, it's 30 past the hour for the read rss.py script, and then it's 45 minutes past the hour for the actual summarization. And then for all of the rest of these values, you just put stars, which indicates that it will run every hour, every day at this time. And so you can play around with these. Perhaps you only want this to run once a day or during a particular hour. So for example, if you wanted to run every day at 4:30 in the morning and then 4:45 in the morning, you would just change the number here. And then you have to essentially put the full script, the full pathway to the script. And in my case, I've put Python 3. I had to specify that specifically. I can't recall why, it just made it a little bit easier. It really will depend on how you've configured your Pi and Python on your Pi. But in my case, I think the default Python installation was Python 2 when I typed in Python. And so to specify that I was going to use 3, I had to put Python 3. And then, as I said, you have to put the full path to where your script lives. And so in my case, I have it in my Pi directory, which is a kind of a default directory that is set up when you set up your Pi. And then I've created a Newsomatic directory. And then I've also set up a little bit of a log file here just to see a little bit of the output from the cron jobs in case anything goes wrong. And again, with that as well, you have to have the full path to the place where the log file lives. And the file that I'll link to in the description of this video will give you a little bit more or a better background on how you can configure cron jobs on the Pi. But that's essentially how I've done it. I run each one of these scripts once an hour, and I have created a little log file for each one of these scripts. But you can also, and then when you're done, you would just want to save it. So there you go. So you don't necessarily have to set up a Crontab if you just want to play around with this. You can also run these scripts just manually. So here's all of the stuff in this directory. This is probably more than what you have in the repository. But if I wanted to run the read RSS, I'll just go Python 3 read rss.py, press enter, and then it will read, and I won't let this all run, but essentially what it's doing now is reading the RSS feeds in my case from the CBC, checking if they are in the database, and if they are not, it is adding it. In my case, it's inserting them all because I haven't actually run this script in a little while. You can see it's going pretty quickly. It does one probably every 5 seconds or so. And essentially what it's doing is it's reading the RSS feeds, it is then scraping, and then it's putting them into the databases. So you'll see if we were to run this again shortly after this is complete, you'll see that there'll be another message that it is already in the database. So I won't run through all of this, but this essentially will go for a couple of minutes. And you can see now after a couple of minutes, this script is complete. And now all of these entries have been added to the database. If we were to run this script again, so again, Python 3 and then space read rss.py, you can see that now it'll find that it's already in the database. It has found essentially what it does is it compares the URLs in the databases, in the database already to the URLs that you have read in from the RSS feed, and if it finds it there already, it doesn't add them. And as I mentioned, in my case, I've cleaned up the URL a little bit, removing all of this information that is after the question mark. So that's essentially how the read rss.py script runs. As I mentioned, the next step that you could either do manually or with a cron job would be then to summarize these articles. And so same kind of format, Python, in my case, Python 3, this might be just Python depending on, or Python 3.7 depending on what you're working with and how your Pi is set up. But I run Python 3 and then summarize.py and let it run. And as I mentioned, this takes a little while. This message seems to happen every time I run. Doesn't seem to affect it, this little warning here. And then it gives a no model was supplied, so it defaults to whatever this distilbart-CNN model is. And so it'll kind of sit here for a little bit before it starts to summarize the articles. As I said, this is a bit of a slow process, so I won't run through all of them because it will do maybe one summarization every minute or so. And you can run this script on your own. You could probably set up your own desktop or laptop computer to do this script as well, and it'll go far quicker. So again, the Pi is a little bit limited on its CPU power. And so you can see it summarized the first article. We'll see in a second that it'll do another one, and then we'll probably stop it just to give you a sense of, the speed, at least in the case of the Raspberry Pi 4B with 4 gigabytes of memory. And eventually it will show a second line that says summarizing article, probably ID 825, which is the next article in my database that hasn't got a summary. And at this point, the Raspberry Pi also gets quite hot. If you were to, again, with my passive cooling, if you were to measure the temperature, it is usually, in my case, about 80 degrees Celsius, which is quite hot. And I imagine it doesn't get over that amount because I believe that once the Pi recognizes that its CPU is getting too hot, it starts to throttle it a little bit. And so you might actually have better performance if you had some form of, there you go. So it just took about a minute or so, and it'll continue like that. But as I was saying, you might get better performance with some type of active cooling based fan system on your Pi CPU, because I imagine that it probably would not have to throttle in that case, but that is something I haven't really tested. So just keep in mind that this takes quite a bit of time. And so in this case, where I've essentially added probably 80 or 90 new articles to the database, all without summaries, it will actually take maybe an hour or so to do all of those summarizing. But in my case, once I've caught up to have those 90 kind of summarizations done, it usually will only do about 3 or 4 an hour. I guess it really depends on how much information is being added to your RSS feeds, but you'll find that this process is a lot quicker if it only has to do 3 or 4. So that's essentially how the summarization runs. And I'll stop it because I don't want to go through and watch all of these be summarized, but it essentially will take maybe 30, 40 minutes to an hour to summarize, in my case, all of these new articles. So now I'll quickly run the create news script. This is, as I've mentioned, the script that will both will essentially create a text script and play a MP3 over the Pi's speaker connection. So essentially, you could probably set this up so that it was it would automatically start and run when your Pi starts, but I still do it in my case manually because I'm still kind of tweaking things a little bit. But like everything else, you could just Python 3 create news.py, give it a minute. And then essentially it just asks you to press a button. So I have my button set up, and I have my knobs currently all set to low values so that they're all kind of at 0, which essentially means you'll get equal amounts of each one of the topics when the newscast plays. So I'll press the button, and it'll start building the newscast. And in a second, you'll probably hear a little bit of the audio playing over the speaker. Maybe I'll turn it up a bit. But you can essentially see that it's now playing. Gives you a little bit of utility information. So you can see here that each one of the volume knobs, there's 5 of them in my case, are set to the same value because none of them have been moved beyond that 0 value. It's not absolute 0, but it's pretty close. And it also, in my case, gives you an outline of how many items from each one of those topics is going to be playing as well. So again, I've set mine up for 10 items, and each one of the subject matter, so Canada, world, business, sports, politics, is going to be 2 because they all have the same value, and essentially it uses it as kind of a weighting and divides whatever these values are by 10. And if I were to press the button again, you can't see it, but if I press it again now, which is what I'm doing, you can see that you could probably hear that there's no interruption in the newscast. So you can't, the button won't register anything else until its current newscast is complete. And if you wanted to stop it, I'll just Control-C this just so we can do something else. But essentially what'll happen is it'll play through that audio file that is created, that output.mp3. And then when it is complete, it will then ask you to press the button again if you wanted to. So that's how it's set up currently. I'll just do a quick, I'll run the program again, but I'll change the knob values a little bit. So I'll turn one of the knobs, the 5th knob in my case, all the way up. And you can see how the values change somewhat. So I'll press the button. And you now can see that the 5th knob, which in my case represents politics, is, when you read the value from the knob, it's actually almost 1. Again, it doesn't get, not in every case anyway, some cases it gets absolute 1, but in most cases it gets close to it, like 99.9%. And what'll happen now is that, as you can see, all of the stories that are going to be in our audio news bulletin are going to be politics. We'll just try one more where I turn up the sports all the way as well. So now both the sports and politics knobs are turned up all the way. And if we run it again and give it a second, I'll press the button. You can now see that I only got absolute 1 this time. So the knob value for politics and for sports is both 1. Everything else is essentially 0. So in this case, those 10 items are going to be split between sports and politics. So yeah, again, if you look at the code for createnews.py, within that, within this, create script section, you'll see a little bit of how that actually breaks down and how it's all divided. Before I finish off this video, I wanted to talk briefly about the laser cut case that I created for this project. So this is not a requirement. You could do this project without a case. You could just kind of leave your breadboard and Pi in whatever case you have and just have everything that way. But I wanted this case to have somewhat of a bit of an enclosure, and so I decided to create a laser cut case. And so I originally had contemplated using a 3D printed case, but the process was a little bit too complex for me at this stage. Again, this kind of fabrication is still completely new to me. And it felt like the laser cut case functionality was far simpler. And so I decided to go that route instead of doing a 3D printed case for this. And so essentially I created 2 different kind of prototypes of a laser cut 3D printed case. The first one was very rudimentary. I essentially created a simple case, tried to super glue it together, and then I actually glued it on top of the case that my Pi came with. I kind of drilled a hole in the top of the case for the Pi and fed all of the wiring from my laser cut case through down the kind of the hole that I drilled into it. And it worked, but I didn't love that case. One of the big things that I learned through this process is you have to be really careful with the amount of space that you give yourself for all of the different components. And so in that first iteration, I really didn't leave a lot of space for the knobs, for the buttons, and even the kind of the DuPont wires and the breadboard itself. They were all very much crammed into the laser cut case. And so after that version, I developed a second one where I was far more conscious of about the amount of space that I was giving myself for all of those different components. And I also, again, I didn't love the idea of that kind of the case that I had already bought, having the hole drilled through it and gluing the 2 things on top of each other. So I created one case that contained both the the Raspberry Pi and the breadboard, and served as a very clean mount for the knobs and the buttons. And so the second case I felt worked a lot better. It's made using black acrylic. And I've used what are called, I guess, these T-slot connectors. And so I didn't, in the second iteration, I didn't use any super glue at all. And all of the connections are made using these T-slot connections and little screws to kind of hold the whole thing together. And I felt that this works a lot better. And I think I didn't want to kind of super glue or kind of cement any of the sides together, because I think there is part of me that is still kind of developing this project. And if I wanted to change how the top mount looks, I could just unscrew it and laser cut something else. And so it gives me, I think, a lot with this project. It kind of gives me an ability to change it after the fact that I might not have had if I kind of cemented all of the sides together. Particularly, one thing you might want to do is just cement all of the sides but the top, but I kind of wanted to do all of them with these T connections. So I won't go through it too much, but you can kind of see that the Raspberry Pi is mounted using standoffs on the bottom piece of the box of the black acrylic. So there's kind of some standoffs, and the Pi is connected through screws through the bottom. There are some holes cut on a couple of the sides for the Pis, for the ports of the Pi. There is also some space on the right for a mini breadboard. So again, this is a smaller breadboard than a full-size breadboard. And then on the top of the case, there was 5 holes for each of the knobs, and then another hole for the button to pass through. So it works a lot cleaner than the version that I had created before. But again, this is a bit of a work in progress. I hope to maybe make a iteration with some type of display screen at a later date. And so I think I will keep this general shape of the laser cut case, but I may move the button to the left to make room for some form of simple LCD display screen, so that I can show some feedback to the users of what is going on. So again, for the most part, that is the Newsomatic project. If you want to see again any of the details of the code for this project, feel free to visit the GitHub repository. And as I mentioned earlier, this is very much a work in progress. In a lot of ways, this exercise, this project was kind of a starting point for me to learn a little bit about physical computing and prototype fabrication. And so there's a lot related to this project that I would like to redevelop, and I'm sure there's going to be a third iteration of this project sometime in the next year. I think in particular, I'd like to maybe try and integrate a speaker into this case so that you wouldn't have to connect an external speaker. I also, as I mentioned, I think I would like to include some form of display, either a kind of simple LCD display or some of those small little OLED displays, to give the users of this system a little bit more feedback on, what are the values of the knob or what is happening at this given minute. That's one of the things that I feel like is missing with it right now. But again, keep in mind, this is a work in progress. And if anybody has any questions, feel free to ask or reach out in the comments.